Hi everyone, I'm Chris. If that causes you any confusion, you can call me Waffles. I want to talk about the project that I worked on with my mentor, Nolan Finch. I wish he could be here tonight, but he's on the road. He actually has to work for a living. So the project that we decided on was to try to work on a Kaggle competition. If you're not familiar with Kaggle, they're a platform for data science and data analytics contests and competitions. A government agency, a private corporation will give Kaggle a data set and they'll pose a problem. They'll put it out to the public and say, can you solve this problem? You can submit a solution and there are cash prizes. Better yet, if you're trying to get a job in this field and you can somehow get up on the leaderboard, this is a good way to do it. So the problem that we chose to work on was proposed by NOAA, so the National Oceanographic and Atmospheric Administration, in other words, Donald Trump's favorite federal agency. They posed the following problem. So what they did was they took a bunch of drones, attached cameras to them, and sent them all along the Pacific coast of Alaska. And they took these photographs, and what they want is for each of these photographs, they want you to be able to count the number of stellar sea lions, and then once you've done that, classify each lion by its type. So it's an adult male, adult female, juvenile pup, and subadult male. So looking at this picture, maybe if you have a magnifying glass and you squint a little bit, you might notice there are sea lions here. There's maybe one or two there. We don't know. So how can we tackle this? Well, actually, so first off, I should tell you what the problem is. Oh, actually, I just did. So NOAA wants to know how many sea lions are in this photo and to classify them. How can I approach such a problem? Well, to help us out, NOAA gave us a training set with 500 images in it. And each of the sea lions in this photo were colored with a single colored pixel, one color for each type. So this is a classic image recognition problem. If you think about something like digit recognition, what do? You build a training set of images of digits, and then you feed that into a neural network, and hopefully it classifies it. I want to do the same thing here. So out of these 500 training images, I want to extract each type of sea lion. Before I do that, though, I want to find where the coordinates are of each of these sea lions are. So where are they located in this image? Once I find that, then I can crop out a 32 by 32 sub-image around each coordinate, and then I use these images to build the training set for a neural network. Okay, so what are some of the challenges that I had with this? First off, I knew nothing about computer vision and image processing. Luckily, my mentor Nolan works for Caterpillar. This is his job. He does computer vision. He works on problems like recreating three-dimensional models from two-dimensional data. So this was right up his alley. He told me to learn CV2. So I started doing that, went through a few tutorials. That was going okay. Started working on this problem. And I hit a wall. I basically bit off more than I could chew. So luckily, he pulled me out of that rabbit hole. That was fine. So then the next problem I had was that I was working locally on my machine with one image, but the data set itself is 96 gig. How do I do that? Well, I've never worked in the cloud before, so I had to learn about cloud computing. He referred me to a Stanford website that had a lengthy tutorial about cloud computing, and then once I've got those squared away, then I can go ahead and worry about the neural network. So let me wrap this up. Some lessons learned. First off, take advantage of your mentor. I didn't do that enough. My mentor was more than willing to help me. Also, if you're applying for the mentorship, think big. Propose a project that you think would be beyond your reach. When I started this, I didn't think I would be actually working on a Kaggle competition, but that's what we ended up working on. And with that, let me say thank you to ChiPy and Array especially for organizing this and for giving me this opportunity, and to Nolan for his time and help.